This is part 2 of the video explaining how to run a one-way between subjects ANOVA in SPSS and how to write up the results from it. So I ended the last video with talking about the fact that in APA style now we just write our p-value here. A reminder that anytime we do have significant results, we also need to, based on APA style, we need to report our effect size as well. So since we did have significant results here, we also need to provide a measure of effect size at the end of this sentence. Had we found non-significant results, we would not do our measure of effect size because we are essentially saying that there is no effect. So since we did have a significant effect, let's talk about how we get our measure of effect size. So, like I said, we only will report our measure of effect size if we indeed rejected the null hypothesis, saying that there is a significant result. We actually have to do something additional in SPSS to ask for the measure of effect size. So this is just another strange and fun quirk about SPSS is sometimes it gives you the option automatically to get the measure of effect size and sometimes not. So this is a situation where it does not automatically give it to you in doing a one-way between subjects ANOVA. It also doesn't even give you the option to get it. So I'm going to show you how we can use the program to actually calculate our measure of effect size. Going back to our data file, it's actually quite easy to get our measure of effect size, albeit annoying that we have to do another analysis to get it. But the way we'll get it is, again, we'll start here by this Analyze drop-down menu, and then you want to go to the Compare Means option again. Here instead, we are going to select this first option that says Means. So once you click on the Means, we'll set this up in a similar way to how we had our ANOVA set up, in that we want to have our factor here in our independent list. So I'm going to go ahead and look through this list for the factor, the one that distinguishes what groups people were in, which was this variable. And then we want to move our dependent variable into that dependent list. So we are comparing these groups on how much caffeine they were consuming. And in addition to this, what you should do is select where it says Options right here. And in this Options menu, you'll see down here it has this option to give you an ANOVA table and ADA. So click the check mark next to that, select Continue, and then OK. Here's the output that we get from doing that. The main thing we want to look for is if you scroll down here, we go to the very bottom where it says Measures of Association. It gives you the measure of ADA, but the measure of effect size that we use for ANOVA is this ADA squared. So the ADA squared is what we are going to report as our measure of effect size for ANOVA. That is all we need. We just need that number, and we'll go ahead and add that to our conclusion. So looking back at our conclusion, I just went ahead and I rounded that number to just 2 numbers after the decimal point. So rounded, it should be 0.07. And then ADA squared we represent with the symbol ADA and then a squared next to it. So that's how we'll report that measure of effect size for ANOVA. So with ANOVA though, we have to do something more. We have to say exactly how these groups are different from each other. So in order to say how these groups are different from each other, what we have to do is we have to conduct a post-hoc test. So recall that you only would use a post-hoc test in a situation where you have indeed rejected the null hypothesis for your ANOVA, and also when you have more than 2 levels or more than 2 groups that you're comparing to each other. So if you only had 2 groups that you're comparing in your ANOVA, which is totally acceptable, you already know which of those 2 groups is different, right? It's just those 2 groups are different from each other. So only when you have more than 2 groups, so 3 or more groups that you're comparing, that's the only situation where you would need to do the post-hoc test. So I'm going to go through an example of a post-hoc test and how to interpret it in SPSS. I mentioned in the last video that there are several different versions of post hoc tests that you can use. It's totally personal preference. You can read more into the literature that pits all of these against each other, but here are some of the most common post hoc tests that I use. So the Tukey test is quite common. It's really only supposed to be used, though, if you have equal sample sizes across your groups. So only when you have the same number of people in each of the groups you're comparing should you really use the Tukey test. Another option, if you don't have an equal sample size across your groups, is to use the Sheffey test. So that would be a good option if your n's are not equal across groups. Finally, another common one would be Denay's T3 test, and this is particularly useful if you tested the homogeneity of the variances assumption and you found that your variances were significantly different. This post hoc test helps to control for that issue. So those are just some of the post hoc tests you can use. We saw in the last video that there are a ton of options. So whichever one you want to use, you have to just choose one and stick with it. So if you're unsure of how many people you have in each of your different groups, an easy way to identify this would be to look back at your descriptives in your output here. It tells you how many people you have in each group. So that helps you determine which of the post hoc tests would be appropriate to use. So since these n's, the values for our n's, are not equal across our different groups, that would mean that the Tukey test would probably not be appropriate for us to use here. So we're going to go ahead and use the Sheffey test. In addition to that, before we even look at the output for our post hoc test, I think it's easier to write down which pairs you have to compare. So our post hoc tests just compare two means to each other at a time. And so it's easiest to first write down just all the different pairs that you have to compare. And the reason for that is because the table that's given to us in SPSS is actually quite redundant. It gives us the same information a couple of times. So I'm going to write down all of the different pairwise comparisons I have. So first off, I have the pairwise comparison of comparing the people who study in advance to the people who study last minute. So group 1 to group 2. Another pairwise comparison I have to make is comparing group 1 to group 3, or the people who study in advance compared to the people who don't study at all. And then the final pairwise comparison I have to make is comparing group 2 and group 3, which is the people who studied last minute to the people who don't study at all. So even though, these are in a certain order, it doesn't really matter which one's first versus second. It really just matters that each of the different pairs that you can combine is addressed in each of these. So anytime you have 3 groups, you're going to do 3 different pairwise comparisons like this. So let's look to our SPSS output to evaluate our post hoc test. So as I mentioned before, our Tukey test would not be appropriate. So even though it gave us the output related to the Tukey test, we don't want to look at that. We actually instead want to use the table, or the part of the table down here that's for the Sheffey test. And so I put an X through the Tukey test so that we can ignore that part of it. So the way this is set up is it will have one mean that you're trying to compare to the other one. So our first pairwise comparison that we were doing was we were comparing advanced, so people who study in advance, to the people who are studying last minute. So we're comparing those two, and the main column you want to look at here is going to be your sig column. So again, we're going to compare that to our alpha level. Anytime it's less than our alpha level, that means that is a significant difference. So since that value of 0.025 is indeed less than our alpha level, we would say that the difference between advanced and last minute studying is significant. So the way I'm going to do that is I'm going to go back to my notes over here, and I'm going to put a little asterisk next to that pairwise comparison to indicate that the difference between those two means it was significant. Now let's look for this second pairwise comparison in our table. So next we want to compare advanced to not studying at all. So looking at our Posthoc table here, we're trying to compare advanced to not studying at all. So that would be here in this row. So again, we want to compare that sig value or our p-value to our alpha level. In this case, this value is not less than our alpha level. So anytime our value is not less than our alpha level, that means it's a not significant difference or non-significant difference. So the way I want to indicate that back on my notes here is I'm just going to put an NS next to that pairwise comparison to indicate that these two groups weren't significantly different from each other. And then last but not least, we want to compare the last minute group to the none, not studying at all group. So again, we're trying to compare last minute to the not studying at all. So we're going to look in this row here, and we'll compare that to our alpha level. That is definitely not less than our alpha level of 0.05. So since it is not less than our alpha level, we again will make the decision that it's a not significant or non-significant difference. So again, I'm going to put an NS next to that pairwise comparison on my notes. So I'm going to use these notes now to finish up writing my conclusion to represent this post-hoc test findings. So here we're going to add to our conclusion. So we ended our conclusion right here before, so now I'm just adding these findings for my post-hoc test. So I'm going to say a Sheffe post-hoc test revealed that students who study in advance, so we report the mean for that group, which I just got up here from my descriptive statistics. That is their average amount of caffeine that they consumed. So they drink significantly less caffeine than those who study last minute. So again, I got that group's mean from up here in our descriptive statistics. So based on these means, we have people who are studying at the last minute were consuming more caffeine, about 7 per week, versus the people who are studying in advance only consumed about 4 caffeinated beverages per week. So that's the first pairwise comparison we have. So now let's talk about writing up the second pairwise comparison, comparing advanced to not studying at all. We would say something like, students who study in advance did not significantly differ from those who do not study. You'll see that I added just the mean for that not studying group in. I didn't need to add the mean for the people who study in advance since I already reported that in the previous sentence. So just make sure you've reported each of your means for your different groups once. But our post-hoc test found that those two did not significantly differ, and then the same thing went for the third pairwise comparison. We found that students who study at the last minute did not significantly differ from those who do not study. So I don't actually need any means in this sentence since I reported the means for each of those three groups already. So that is how we'll finish off that conclusion there. It might seem a little strange to you that these first two groups differed from each other, but the third group did not differ. The main reason for that is the fact that we only had 4 people in that group. So this sample size is much, much too small to conclude anything about that group, which is probably why it wasn't identified as being a significantly different mean, because that sample size is really insufficient to conclude anything about that group. So that's why it kind of looks a little strange. We really shouldn't have done an ANOVA with a group of less than 30 people, but it's useful for an example to go through. So here we are. So hopefully that helps walk you through a little bit of how to write up the results from a one-way between subjects ANOVA.